Good morning, everyone. Today we are going to study about lasers and their different properties, how they are different from other light sources. First thing that we know about lasers, that is the focused lights they are having here. They have very focused light that is not very much dispersed in the surrounding when it is incidented at some object. Now look, this is a picture of a laser which is focusing its light at some place on some screen. Now, actually, what is the laser? Laser. It stands for light amplification by stimulated emission of radiations. So it is actually an amplification process in which the production of light that is stimulated. It is not eventual, it is induced by some other object, some other effect, with the help of which we can amplify the effect of production of light radiations. Now, what are the different properties of lasers which make them different and more efficient from other light sources? First property is monochromaticity. The lasers are monochromatic. Monochromatic means they have single value of their wavelength as well as frequency. Now look at this. If a material is monochromatic, its power that is focused at some point. It is less widened over different angles, so focusing is much easier. Two examples of lasers are helium neon and diode laser. For helium neon, the wavelength is 632 nanometers with a small delta lambda, that is this one. This is delta lambda. How it is wide spreading angle. This is zero point 0.2. But for a diode laser, which is having more wavelength as compared to helium neon, but its delta lambda value is 10 nanometer, which is more than helium neon. So in comparison of these two, helium neon is much better laser as compared to the diode lasers. Look at this. It's a dispersion pattern of a white light through a prism. The comparison of wavelength of red light and blue light. Here red light, it is going to have more value of wavelength as compared to the wavelength of blue light. So in inverse, blue light is going to have more frequency than red light. Second property of lasers is directionality. Means the direction in which the light from a laser is incidented. In case of a regular bulb light source that we use, it is in all the possible direction, the rays, the light coming from that source, that is totally widespread. But in case of a laser, it is only spreading in a fixed direction. So the light coming from a laser source is very much directional. Second thing, why the important characteristic of directionality is beam divergence. Means the light which is diverging from its actual path. In case of laser, it is a very good property for of beam divergence. Third one, that is the most important property, that is coherence. Coherence means it is going to the phase difference between two wavelets which is coming from the same source. Incoherent waves, look at this. One is having crest over here, other is having here. Third, second crest, they are not matching. Look at this. They are different place. But in this case, look, there is a total pattern, a complete matched pattern in which all the waves they are having same phase, almost zero phase difference, or if there is a phase difference that would remain constant. That is the property of coherence. Now, let's have a comparison between incandescent and a laser light. As we have already studied the three properties, which is monochromaticity, directionality, and third one is divergence. Now we can have, it is not at all directional. It is widespread light, incandescent. It is not monochromatic, it is having polychromatic light. Polychromatic means it is going to give us large amount of wavelengths from the same light source. Other one, it is totally monochromatic, it is totally directional. Look at this. Yeah, and this one is going to have this wavelet. This is representing different one, not even a directional, but the laser, they are all of them, they are coherent as well as a direction. They are not widespreading, they are going in a same direction. Now this is going to have large number of wavelengths, multidirectional, incoherent. In case of laser light, it is monochromatic, directional, coherent. So this was all basic about lasers. In our next lecture, we are going to discuss about the principles of lasers and how the lasers works. Thanks a lot. Keep me watching on my YouTube channel, Physics Classes by Dr. Dishan. Have a great time ahead and enjoy our lectures.